Alright, we're trying to see the minimum speed to get a roller coaster to travel over the upside down over the loop. We know that the loop itself is 7.4 meters in radius. So if we look at here's our little car. If we look at the forces on the person in the car, okay, the person is sitting in a seat. Person is sitting in a seat, and he or she has some forces acting. Definitely a weight, but then also a normal force from the bottom of the seat pushing down. So the net force is towards the middle, which is good because it's circular motion, and that's what needs to happen. And when you go around this thing faster and faster, your acceleration is bigger and bigger because you're changing direction more quickly. You need a bigger and bigger normal force to make that happen. So if you were to go around this loop really, really quickly, you would feel that, feel sort of pushed into your seat. That's the seat pushing on you harder to change your direction more quickly. But if I go the other direction, that normal force gets smaller and smaller and eventually goes away. And so there's a sort of a minimum acceleration that I can have. And that happens when the end gets small, and at some point it goes away, and that is our minimum speed situation. Okay, we're looking for the place where you just lose contact with the seat, right? Any less than that and you'd be in trouble. So the F-net's pretty easy. We know the direction positive towards the center, as always with circular motion. F-net is just mg, which will equal ma. Since it's circular motion, that's v squared over r. And we can solve for the minimum v. Notice that the mass canceled out, so this answer doesn't matter. It doesn't matter how much the person, the rider weighs, which is good from a ride designer's perspective. Okay, so square root of rg, which is 8.6 meters per second. It's about, it's getting close to 20 miles per hour, like 18 miles per hour. So that's not too terribly fast. That should be pretty easily achievable. The big part of this thing is thinking about the condition, when something loses contact. That's when we're talking about the normal force going away.